Chapter P is our prerequisite. It's the stuff we need to know before from Algebra 1. We're going to start off in Section 2. Today we're going to talk about integer exponents. In a couple days we're going to talk about negative exponents. We're going to talk about fractional or rational exponents. But today we're just talking about integers. So let's talk about exponential notation. And again, if I'm talking to you and you're looking at me like I already know this, that's fantastic. But when we talk about, exponential notation, all that is repeated multiplication. So in a case like this, if you have 2 to the 4th power, the base is the 2. The bigger number is the base. It's the 2. So I have my 2 here, and it's raised to the what? It's raised to the 4th power. What that means is I have 2, and I want to multiply it by itself how many times? 4 times. It's repeated multiplication. You say that as 2 to the power of 4 or 2 to the 4th power. So if you have x to the 6th, how many x's do you have? 6 being multiplied together. Thank you. So just an example, you have 5 x's multiplied together. You can write that as x to the 5th. You have the quantity of 2x, because it's in a parenthesis, 4 times. So it's 2x parenthesis to the 4th. This would be negative y to what power? To the 5th power, because there's 5 of them. This would be 1/2 to what power? 7th, because there's 7 of them. Good. All right, just remember how to do notations and stuff like that. Now we're going to talk about 2 different exponent rules. We're going to talk about what we do when we multiply bases that are the same, and then when we raise a power to a power. So if you have bases that are the same and you're multiplying them, a simple way to evaluate is just to add the exponents together. So in this first example, you have x to the 3rd times x to the 4th. The bases are the same. The base is the x. So the way that you would simplify that is to rewrite it as 3 plus 4 is 7. Because what this is saying is x to the 3rd looks like this, 3 x's, and x to the 4th looks like this. So how many x's do you have total? 7. In the next example, what's a little different is you have something called coefficients. Coefficients are the numbers in front of variables. Since you're multiplying, what is 3 times 2? 6. Then I notice that I'm multiplying the same bases. My base is x. I have 4 of them here. I have 2 of them here. So we add them together, and I get x to the 6th. Right? How many of us remember this a little bit from Algebra 1? Super. Well, good. I just taught you something new. All right, here we go. Let's look at number 1. Evaluate the situation. What's going on? Are you adding here or are you multiplying? We're multiplying. That little raised dot means to multiply. So I have the same base. I'm going to rewrite my base. Since my bases are the same, what do I do to the exponents? You add them. What is 6 plus 3? 9. This is y to the 9th. Let's look at number 2. I have coefficients, right? I have numbers in front of variables. We're just going to multiply those together. What is negative 4 times 3?
Negative 12.
Perfect, negative 12. And then I notice I have x to the 4th and x squared. So I have the same bases that I'm multiplying together. I'm going to rewrite the base. And then what do I do to my 2 little exponents? I'm going to add them together. What is 4 plus 2?
6.
Perfect, good job. All right, 3. 3 is a little longer, but the process stays the same. I just happen to have an additional variable here. I see my 2 coefficients. I have a negative 3 and a 5. What is negative 3 times 5? Perfect, negative 15. Then I have the letter A. I got an A there and an A there. So I'm going to rewrite my A. But in order for me not to make a silly mistake, because there's a lot of places you can make silly mistakes here, I'm going to put a little 1 right here. Why am I putting a 1 on that A? If there is a letter, you see it, you visually see it, but there's no exponent, what do we assume the exponent is? 1. Why is that a big deal? Does it matter, like if you guys have x, does it really matter if there's a 1 there? You're like, what, do I really have to put it? No. But when there's exponents, I think it's a good idea to, because when you have the same base that you're multiplying and you're adding, some of us forget that that is a 1. And to add 1, 3 plus 1 is what? 4. It's not 3. I always put a 1 if there's not one there. I always just put it there. And then I'm going to look at my last variable. I got a b there and a b there. So I'm going to rewrite the base 1 time, and I'm going to add the exponents together. What is 4 plus 2? Perfect. Good job. Anybody have any questions so far? We okay? All right. So what's that little thing I just told you to do to make yourself make it a little more clear? Where should I put a 1? On the M. Good. Very good. Right next to the M. So I'm multiplying same bases. The first base I see is an M. I have 1 of them here and 3 of them here. It gives me a total of 4. Perfect. Then the second base I'm looking at is N. I have 2 here and 3 here. Gives me. Perfect. Good job. Are we still multiplying here? Yep, we're still multiplying. If there's a raised dot in between, you're multiplying. If there's just 2 parentheses stuck together, you're multiplying. So this just happens to have 3 different things. So I'm going to use my coefficients first. Negative 3 times 2 times 6. What's negative 3 times 2? Negative 6 times 6 is? Perfect. Negative 36. Now I see x's. I have 2 there, 1 there, 5 there. So I'm going to rewrite my base, and then I'm going to add 2 plus 1 is 3, plus 5 is perfect. Then my second variable of y, I have 3 here, 1 here, 2 here. So 3 plus 1 plus 2, perfect. On number 6, guys, in that first parenthesis, what is in between that negative sign and the x? What number's there? There's a 1, okay? Don't forget that. So I have a negative 1, a negative 2, and a 6. What's negative 1 times negative 2? 2. Then 2 times 6 is 12. Perfect. So now I'm going to look at my x's. I have an x, I have 1 there, and I have 2 there. I'm going to rewrite my base and then add my exponents. What's 4 plus 1? Plus 2? 7. Good. And then I'm going to look at my y's. I'm going to rewrite my y. I have 1 there, none there, and 5 there. So what's 1 plus 5? There you go. Good job. Second thing we're going to talk about. I just have 6 more examples, then we're done. When you raise a power to another power, all right? What that looks like. I have x to the 3rd to the 4th power. In this case, guys, we do not add the exponents. We're going to multiply. When you have a power raised to a power, you're going to multiply. Power raised to a power, you have to multiply. Now, what do you notice about this? This is 2x to the 4th times 2x to the 4th, right? So we would take our coefficients and multiply them. 2 times 2 is 4, right? And then I have the same base, so I rewrite the base, and I add the exponent since I'm multiplying. 4 times 4 is 8, right? Well, the shortcut to that, and what we're going to focus on, is we're going to distribute that exponent. Whenever you have a number outside of a parenthesis, we always distribute. In this case, it's an exponent. So I'm going to take this 2, and I'm going to distribute it here, and I'm going to distribute it here. So this becomes 2 squared times x to the what? If I raise a power to a power, what do? Multiply. So 4 times 2 is 8. And then we simplify that a little more. What's 2 squared? 2 times 2 is 4, so I have 4x to the 8th. All right, that's what we're going to do. For all these problems, we're going to distribute the exponent and then simplify. So let me show you. I have nothing to distribute to. It's just a power raised to a power. So if I have a power raised to a power, what do? Add or multiply? We're going to multiply of x to the 6th. Perfect. So in the second one, I have 2 different things inside that parenthesis. So I'm going to distribute. I'm going to take this 2. I'm going to put it on here on the negative 4 and to here. So this says negative 4 squared, which means negative 4 times negative 4. And then this is x to the what? Power to a power. What do? Multiply. So 4 times 2 is 8. Good. And then what can I simplify negative 4 times negative 4 to? What's negative 4 times negative 4? 16 to the 8th power. They're spraying for something. A negative times a negative is a positive. Good. All right, again, where is that little 2? Is it on the inside of the parenthesis or on the outside? Outside, so that means we have to distribute it. It's going to go here and here. So when you raise a power to a power, we add or multiply? We multiply, so this becomes a to the what?
6.
Yep, and then b to the second. Because there's a little imaginary 1 there, right? 2 times 1 is 1. I'm sorry, 2 times 1 is 2. Good math. I'm tired. All right, got that little 3 on the outside. So where does the 3 go? I distributed to the 3. I distributed to the m and to the n. So this becomes 3 cubed, m cubed, n cubed. What is 3 cubed? 3 times 3 times 3. Yep, 27. Write it out. Good job. Again, same thing. Where is that exponent? Is it on the inside or is it on the outside? It's on the outside, so we need to distribute it. We need to distribute it to here and to here. So this is negative 3 to the third power. And then x what? If I'm raising a power to a power, what do? Multiply, so this becomes a 6th, right? What's negative 3 times negative 3 times negative 3? Negative 27, then I have x to the 6th. Last example, and then you guys can start your homework. Remember, we're not sitting and chit-chatting. We're going to start our homework. We're going to ask questions. You can work together if you need to, but what do I do with that little 2? I'm going to distribute it. So I'm going to go here to the 6th, and then here to the y. So 6 to the second power, y to the what? 10th. How come we did not add 5 plus 2? Because we're raising a power to a power, right? If we have same bases that we're multiplying, we add, but we don't. We just have one letter. When I have power to a power, we're going to multiply. So what is 6 squared? Don't tell me 12. 36. Remember what that means. If you need to write it out, 6 times 6, so you don't say 6 times 2. That's what you guys need to do. All right, we're going to finish up this lesson tomorrow. If you have any questions on today's stuff, please feel free to ask me. But you should be able to get your homework mostly completed. That's not due till Friday morning. You can probably get most of it done today. But look at it. Ask me questions. You have plenty of time now to do that.